So today we'll be looking at the areas of triangles, and this may seem like some revision to you, but there will be some new content and a couple of new formula that we'll have a look at. Okay, so we'll just start by looking at a couple of triangles, and what we've got labeled on them is their height, h, and the base length, b. So the dashed lines are not part of the triangle, just the solid red lines, and we know that the area equals half the base times by the height. Okay, now we can simplify this. We don't have to write it with the full words. We can write area equals half b h, or b times h, same thing. So we know this formula, and we're going to have a look at a new one today. So first up, we'll just do a quick example. So what I want to do is just label my triangle here. I know a few sides, but I know my 14 is my base, and my height is from the base to the highest point, which is this 5 here. So I know my h is 5 and my base is 14, so my area equals half base times height, which equals half of 14 multiplied by 7. And if you put this into your calculator, you'll end up with... So let's have a look at an example now. And what I've got here is a triangle. We know the base is this bottom part, so I'm just going to label that the base. And the height is the distance from the base to the highest point. So this 5 represents the height. Now if I put into my formula, area equals half base times height, and just from there just substitute in what I've written down. So the area equals half of my base, which is 14, times my height, which is 5. I just substitute this into my calculator or just work it out. Half times 14 is 7, times by 5. So my area equals 35. Okay, and we remember that area, if let's for example say these were in centimeters, it would be in centimeters squared. And that was if all of these measurements were in centimeters. If they're in kilometers, it'd be kilometers squared, and etc. Okay, so we're used to using that formula, and what we want to do is just derive another one in case we cannot, in case we do not know our height. All right, if we just know the side lengths and some angles. So what we want to do is we want to develop a formula for our height, and we notice that if we ignore this part of the triangle, if we ignore this part for now, what we've got is a right angle triangle, and we want to work out our height. So we know we want to work out the height. We also have this length C and this angle B. So what we're going to use is one of our formulas, trigonometric formulas. So what we've got is our angle B here. So our H is our opposite. So I'm just going to label this opposite. And our C is our hypotenuse. So we've got opposite and hypotenuse. That's always our sine formula. So sine of our angle B equals our opposite over our hypotenuse. So our opposite is our height divided by C. Okay, so I can rearrange that. I can multiply both sides by C to get height by itself, and I'm left with C sine B equals my height. Now what I want to do is substitute this back into my formula that we've been using. So we know that the area equals half the base times by the height. So our base is this length here, A, and our height is this one here. So we can write that out again. Area equals half of our base, which is A, times by our height, which is now C sine B. So our area equals half AC sine B. Okay, so that's actually one of the formula. There's a couple of variations of this, but they all basically stem from this kind of derivation. So from that derivation, we were able to get the equation area equals AC sine B. Now this is also true for these two formulas, so this is all the same. And what these mean is if we have a triangle with side lengths A, B, and C, we know the angles, we can label them with a capital, the opposite. So C, this one here will be B, this one here will be A. And if you have a look at this formula, what we need to know is we have to know to work out this two side lengths and the angle between them. So if we know C and B, we have to know A and we can work out the area. So that's this formula here, B times C sine angle A. If we knew C and A, we'd have to know the angle between them, which is B. So this would be AC sine B. And finally, if we knew A and B, we need to know the angle between them, so we get AB sine C. Okay, so if we know two side lengths and we know an angle between them, then we can work out the area of any triangle. Okay, so let's have a look at an example now. So the first thing I want to do, and this isn't necessary, but to start with, I would highly recommend it, is I want to label my triangle. So I'm going to label this A, this B, and this C. And this doesn't matter. It doesn't matter what you label it as long as you're consistent. So if this is C, it means my opposite angle is capital C. Opposite A is capital A, and opposite B is capital B. So what do I know? I know my A, my B, and my angle C. So if I head back to those formula on the previous page, I know A, B, and C, so I'm going to have to use this first formula here. Area equals half AB sine C. So my next step is to write that out. Area equals half AB sine C. And then just substitute in from there. So that's half of my A is 100 times by 200. Sine of my angle was 60 degrees. And then I just put that into a calculator. So I've just checked in my calculator and I've put in sine of 60 degrees and I'm getting a negative number. Now this doesn't make sense. And the reason for that is because I'm not in degrees at the moment. I want to be dealing in degrees for my angle. So if I press shift and setup, I can go down and change my angle to degrees. And if I press enter again, that will give me the right answer. So what I want to do is, from the equation, I want to do half. So 0.5 times 100 times 200 times by the sine of 60 degrees. And I get 8660.25. So that equals 8660.25. Okay. So I'm probably going to round that off to three significant figures, seeing as I was given 3 here and 3 here, even though I was only given 2 there, but I would round this off to 8660. Okay, again, the units would be squared units, but we haven't been given a thing here, units here, so I'd write this as units squared. Okay, so that's how we deal with a triangle when we don't know the height. Thank you.